Most of us are familiar with naming compounds using oxidation numbers. We're used to doing this with transition metals. So if you see something like FeO or Fe2O3, all right, we typically will work out the charge. We usually base that on oxygen being too negative in this case, and we figure out the charge on the iron. And then we go and we would name the compound as iron 2 oxide for FeO, and we would name Fe2O3 iron 3 oxide. Okay, the Roman numerals 2 and 3 refer to the charge that is on the iron atom. Okay, in grade 10 we referred to this as charge. Now we can call it oxidation state, oxidation number. It's essentially the same idea, right? We have seen that oxidation numbers are artificial, but we also know that based on the rules that they will be the same as the charge on the iron atom here. Okay, what about when things get a little bit more muddled? When we see something like SO2, SO3, S2O3. These are three covalent molecules, all of which have sulfur and oxygen in them. All right, we do have a way to name these using the covalent rules, but I should also be able to account for the varying oxidation state of sulfur in this one. So let's have a look at this in a little bit more detail. First, we'll start with SO2. Okay, we would know from our rules, you can go back and check the 7 rules that we developed together. Each of the oxygens would have an oxidation state or an oxidation number of -2. Because this is a neutral molecule, this means the single sulfur atom present must bring +4 in terms of oxidation number. So this would be named sulfur 4 oxide. The 4 is in reference to the +4 charge that would be found on the sulfur atom. SO3, again, each of the oxygens has an oxidation state of -2. Okay? This means sulfur must be +6. So that single sulfur atom present brings all the +6. So this is sulfur 6 oxide. S2O2, each of the oxygens has an oxidation state of -2, which means the total sulfur oxidation state must be +4. There are 2 of them in this case. Each one of them would get an oxidation state of +2, so I would write the name of this compound as sulfur 2 oxide, because again, the Roman numeral 2 is in reference to the charge of the sulfur. I could also, just for completeness, we could re-examine the covalent naming system for this. This would be sulfur dioxide for SO2, sulfur trioxide for SO3, and disulfur dioxide for S2O2. The 2 naming conventions are used interchangeably. Obviously, when we discuss oxidation reduction reactions, we're more likely to ask about the Roman numeral naming system.